So for today, we needed to start with this problem. R equals cosine theta. First off, you should know that if you graphed it, would look like a circle and generally be over there. And if it had a number like 5 in front of it, it would just have a much wider, it would go out to 5 here instead, and it would be like that. All right, so there's your first part of your problem. Then if I say also, I'm going to give you another one, R equals 1/2. Well, that'd be a circle that looks like this with a radius of 1/2. And where exactly would these guys meet? Well, these two spots. I'm going to make them green. That spot and that spot. So how do you tell where they intersect? You just stick the one equation in the other one. Since R is 1/2, and here's an R right here, let's replace that R right there with a 1/2. And let's not have it be a 5. I just wanted to show you that if it had a 5 in front, it'd just be a bigger circle. Now that I've said R is 1/2 and I stuck the 1/2 where the R was, now I just have to solve this. And this is supposed to be automatic for you guys by now. All students take calc cosine is positive here and here. And cosine is adjacent over hypotenuse. 1, 2, must be a square root of 3 there. And that's a 2 and a square root of 3 there, but it's negative because you're going down. And then this answer here and this answer here are your two answers. All right, and this one's across from the root 3, so that's a 60, aka pi over 3. You had a pi over 3 as one of your answers. Awesome. And the other one is, well, I know you're going to be tempted to say negative pi over 3 because it's just like so easy to go down like that. But is this inverse straight? Did anything say inverse straight? Was there an arc? Was there a -1 power? No. So therefore, we always give positive angles unless it's inverse straight. So it's a whole bunch of pi over 3s. This here would have been 3 pi over 3. So for 5 pi over 3, there's your two answers, pi over 3, 5 pi over 3. Now, I want to challenge you on that for a second because I get a lot of people had that. Here's your pi over 3 one. It goes up like that at pi over 3. And here's your 5 pi over 3 one. But isn't it supposed to be a point? Did anybody answer with an r comma theta and therefore a radius of, well, it was in the problem. It said r equals 1/2. 1/2 comma pi over 3 and 1/2 comma 5 pi over 3. Now, I understand the instinct to just like solve this and get these two answers, but it says in a problem today in the homework, and also, you'll see this eventually on your test, that you have to find intersection points. So if it's a point, you got to give your r along with your theta. Okay? Question?
Would it be like 2 because that's like the distance?
2.
From the origin to the point? Or would it be just 1/2?
I want to challenge you on the whole 2. That blue circle that I just drew, just to kind of show you what it would look like. What's the radius of that circle again?
1/2.
And therefore, isn't this length
Yeah.
1/2? Okay. All right. So, we'll see another one like that in the notes in a minute. I want to hit you with a couple other ones that I think are hard and while I still have your best brain going at the beginning of the hour. And this is all to get you ready for this test that you're going to have tomorrow. I think the next thing I'm the most worried about is you having to graph something. So let's do r equals 2 cosine theta. And let's graph it. But I'm going to tell you some points that you should put in. It's always r comma theta. But I'm going to tell you some thetas that would be smart to put in. Put in theta is 0. Put in theta is pi over 3. Put in pi over 2. That probably is enough. If you can do those 3, you could do more if you had to. So just try those 3. And then once you've found those points, graph them in polar. You'll have the r's, you'll have the thetas. To me, that's probably the hardest question, because you got to do like a whole bunch of parts right, a whole bunch of little points correctly to get your graph. All right, in case you're like, I don't know what to do here, let me help you. This one is r equals 2 cosine of, well, it says 0, so it's 0. And to find cosine of 0, I'm going to go over here and do my quadrantals, because a lot of times we pick quadrantals because they're nice, because they always come out to 1s or 0s. All right, so if I'm going to find, this is 1 comma 0, this is 0 comma 1, negative 1 0, and negative 1, nope, 0, negative 1. Then, if I want the cosine, that's the x value. So, I'm going to circle all my x values. So, what did I want? I wanted cosine at 0 degrees. Cosine at 0 degrees is right there. It's a 1. Okay? So now this is turned into a 1. Is my answer r equals 1? No, that part's 1. R equals 2 times 1, so you should have had a 2 there. Okay. Ashana, can you do the pi over 3 for me? Starts with r equals 2 cosine of pi over 3. I'm drawing a little triangle so that you can save some time here. And this is going to be a 60. Okay. Okay. All right. So tell me what cosine of pi over 3 is. Yeah. So this part here is a half. Yeah. So 2 times a half is 1. So r equals 1. So then that's a 1. It's a strange noise. You guys know what that is? Is that a bird, actually? I'm pausing. All right, so I am now going to put in pi over 2. And Anya, would you please talk me through r equals 2 cosine of pi over 2?
Yeah, so you're gonna pi over 2 is a quadrantal, so you'll take the x value, which
Is this the right quadrantal?
yes,
Okay, good.
and you'll take 0, which is cosine of pi over 2, and 2 times 0 is 0.
So that part is 0. So then 2 times 0 is 0. So r equals 0. So can you have r equals 0? Absolutely. It's a thing. But where do I graph that? Yep. This, to be actually graph these now, I'm going to make myself move my graph over a little bit. It's a little bit too crunchy in there. So to actually graph these, remember this is polar now. So it's like a radius 2, but it's not a circle with a radius of 2. It's a radius of 2 at the angle of 0. Well, here's the angle of 0, and a radius of 2 puts a dot right there. Okay, now it's a radius of 1 at pi over 3. Well, here's the pi over 3. How far out do I go? I go out 1. So I'm going to go like right there. And at 0 comma pi over 2, that's at a radius of 0 means you're at 0, 0. Now if I could fill in the rest of the dots for you, it looks something like that. Why? Because it's cosine. And cosine tends to make a circle just to the right of the origin. That make sense? What if I did -1 after it? Take your function and move it where? Down 1. All of the points would move down 1. So now your circle would probably look something like that. Just move down 1. What if I wanted to move it to the right or the left? Oh, you could do that, but bottom line is, I'm not promising you that the problem that we give you is gonna be for sure a circle that's sitting right here, or another one. Sine generally is a circle that's up here, because we might move it a little bit by adding something to it. Like if we add 2 to it, then all of a sudden your circle will be up there. If we subtract something from it, the circle could be down there. What if we reflected the circle? Well, then the circle could go down there. What if we reflected it and moved it? Well, then the circle might go down there and then move over to the right or something. All right, so that's where sine starts, the dotted line one. That's where sine starts. And then you could move it in a lot of different places by adding or subtracting numbers. All right, you need to practice that. And we have a worksheet that does practice that for you. All right, next thing is converting. If I just say r equals 8 and I say convert that to that is polar, convert it to rectangular, you should be able to just really quick change that to a rectangular equation. Well, what are those like 6 things you have to know? Mr. K, are you with me? Excellent, good. X squared plus y squared equals, that's one of the things you have to know. You know what? R squared, good. What's x, Evan?
R cosine.
Excellent. What's y? R sine theta. We are not giving you those on the test. You have to know them. Okay. Is there one more? Yes, for sure. We have sine, we have cosine, so what do we need? Tangent. But this one's a little different because it's not r tangent. You never do r tangent because tangent doesn't depend on the radius. It depends on the x and the y. And here's the picture that goes with this. X, y, radius. And this is why tangent doesn't care about the radius because it only cares about the x and the y. So tangent is y over x. So if you ever see a y over x, you can replace it with tangent. If you ever see an x, you can replace it with r cosine theta. If you ever see an r, well, I just did. There's my r. Not quite as simple as, but man, it'd be really simple if it was an r squared, wouldn't it? So, go ahead. Convert that over. Max, what do you think we should do to both sides? Square them. So you get r squared equals 8 squared. So then you replace the r squared with, and your final answer is that. That is rectangular. All right, let's do another one like that. X squared plus 4x equals y. Convert. And it might be like, well, but I wanted y squared, but I can't really square both sides. You're right. Probably don't want to do that. But each one of these things has something on our list of memorized facts that you can replace it with. Might be like, but there's no x squared over there, but there's an x. And then you can square it. So x is r cosine theta. So if you got this one, you're probably going to get it all. 4 times r cosine theta equals y, which was r sine theta. Now the only pain in the butt here would be if they ask you to solve it for r. It's the only variable left, or theta. And that would be a really brutal one. It'd probably be too hard to solve that one. All right. Then, do you remember there was 2 strategies? And last time we squared both sides. What was the other way you could do it? Because squaring both sides would not be so good in this one. Caleb remembers. Yes, because it still gets you your r squared, and it gets you an r cosine theta. Pausing for a second. So this is x squared plus y squared because that's the same as r squared. Nice. And then the 4r cosine theta?
X.
Just x?
4x.
There you go. So the arc cosine theta part is the x, so 4x. Now, this would be nasty to solve for x, but it would actually be fairly easy to solve for y. Would you please solve this one for y? Lucas, how do you start?
I would probably start by getting x on the other side.
I agree. Minus x squared. Y squared equals negative x squared plus 4x. Anya, next step.
Well, use square root both sides.
Square root.
And then absolute value of y is equal
Nice.
to square root of negative x squared plus 4x.
And then?
You split that into two, a positive and a negative with x.
And could you just combine them together and say plus and minus? You sure could. And it would be negative x squared plus 4x. There you go. Let's solve for y. All right. Now, we kind of started with the hard ones because it's the review day. And I want to give you one that's more of a normal I'm going to give you a point. That is a rectangular point. What's the polar point for it? Always draw the picture, graph it, and you'll be able to figure out the angle. And if you can't figure out the angle, all you do is write inverse tan of whatever. And hopefully you'll be able to figure out how long the radius is, as in the hypotenuse. I'll pause for a second, let me try that. Davis, were you able to graph this thing?
Yes.
Which quadrant's it in?
Quadrant 1.
How far over should I go?
2 square root 2.
How far up should I go?
2.
Now, did you figure out how long? First of all, I wouldn't try to figure out which triangle I was in. I would just try to figure out the third side. So, and then hopefully you can figure out which triangle you're in. Sometimes you're in an unknown triangle. Sometimes you're in the 30, 60, 90. Sometimes you're in the 45, 45, 90. Okay, so just find that third side. Square root of that squared and that squared. What did you think? This one's easy. 2 squared is 4. But how about 2 root 2 squared?
2.
You think it's just 2?
I think
2 root 2 squared
Oh,
is
no.
going to just be 2?
No. It's gonna be 8.
Oh, okay. So that's going to be 2 squared, which is 4. And square root of 2 squared, which will be 2. And the 2 times the 4 makes 8. All right. So then did you get a grand total of the square root of 12? Now, the square root of 12 could be simplified to root 4 and root 3, which is really 2 root 3. I would definitely do it that way. And then I would try to figure out, is there a chance that this is one of those triangles, like the, 1, 2, root 3 triangle or the 45, 45, 90? Well, are these two sides equal? No, so then it's not the 45, 45, 90. Next, is this side and this side a 2-to-1 relationship? Is one of them exactly twice as big as the other one? No. Then this is not either of the classic triangles that we have ever learned. You know what I mean? This is not the 45, 45, 90, or these would have had to be equal. And if it's a 30, 60, 90, this and this would have to be twice each other. The biggest one's twice the smaller one. Okay, so then it's not one we know. So then what do? Inverse tan. So first off, your radius was square root of 12, but you'd have lost points if you didn't simplify it down to 2 root 3, comma, the theta if you don't know it, because you haven't memorized it, then it's inverse tan of TOA, opposite over adjacent. The opposite side was 2, adjacent side was 2 root 2. And there you go. Now, could we get that rationalized so that the root 2 goes on the top? Yeah, but you're just doing extra work you don't have to do. Could you simplify the 2 over root 2? Yeah. You really should simplify everything you can, right? So 2 root 3 comma, these 2's are going to cancel each other. That leaves a inverse tan of 1 over root 2. Now you might feel like you've seen that one before. If this was sine or cosine, if you were doing sine of that or cosine of that, we could do it, but it wasn't. All right. So you have to leave inverse tan when they get weird. All right, next up. I think we should do one more of those intersect kind. R equals 1. R equals 2 sine theta. Figure out where those two intersect. Pause for a sec while you try that one. All right. So just tell me what to do to make an equation out of it, because I got 2 equations and I really only want 1.
Right, yeah. Set the R on the bottom side to 1.
Yes, it's R is 1. We just put a 1 right there. Okay, and then you said to divide both sides by 2. I heard that. And then I have sine theta equals 1/2. Now what?
Inverse sine.
If I do inverse sine, I'm not going to actually get my 2 answers. See, I'm going to get only 1 answer if I do inverse sine. So draw this little thing. And let me make sure you get a picture of what this was. This was a radius of 1 circle. So that's like this. This was sine, which I told you is a circle up above, and it's a little bigger than normal because there's a 2 on it. So then it would look something like that. And the question is, where do they intersect? See how there's 2 answers? One of them's in this quadrant, one's in that quadrant. Okay, so we need 2 answers. So now we're going to do sine is 1/2. So all students take calc. Where is sine positive? Oh, it happens to match up. In quadrant 1, we get an answer, and in quadrant 2, we get an answer. So sine is opposite. Hypotenuse, this is square root of 3. Opposite hypotenuse, square root of 3, but it's negative. Easy to make that mistake. And then actual answers here are angles. So what angle is across from the 1, Caleb?
Pi over 6.
I agree. Pi over 6 is one of your answers, and the other answer? 5 pi over 6. And then the real challenge, remembering that you wanted points. See, these are a dot. And the dot is on the radius of 1. So you should have said 1 comma pi over 6 and 1 comma 5 pi over 6. There are your 2 answers. How many of you pulled it off? Okay, any questions? Do you get that they are points? That's why I'm making them polar points. It's neat. Many of you were able to get to pi over 6 and 5 pi over 6, but that's just circle trading. We've done that forever. This is putting it in the context of polar points. So they needed this r equals 1 in the front. All right. Now we have a worksheet. Basically, it has a bunch of problems that you can use to practice. This would be a very valuable one to practice right here. I think it's the hardest thing on the test, in my opinion, is the graphing, just because you have to do like a whole bunch of little parts right. Each one of them isn't that hard, and this thing looks like notes, and it doesn't look like your normal assignment, but it was made specifically by one of the pre-calc teachers to get you ready for this test. Okay, so I would do all of these practice problems and then do the answer key. But this is going to have to be on you. You do this for practice because you want to get a good grade in the test. Don't do this because you want to like, I don't know, make me happy or something. Do it because you want to understand this. All right, so let's do the first one. R equals, I would write it out each time. It's going to take you like a whole bunch of tries here. But R equals 2 plus 2 sine, and they tell me the angle. So instead of putting theta, I'm going to say 0. Eventually, I'll figure out what R is, and I'll put it right there. All right, so what's sine of 0? Well, 0 degrees is over here. And there's a dot there on the unit circle at 1 comma 0. And sine's the y, so it's 0. So sine of 0 is 0. If you look at the graph of sine too, like here's the graph of sine. What is the sine of 0? It's 0. Makes sense, you start at 0, 0. Okay, so then this is 2 plus 2 times 0, which is really just r equals 2. So that's a 2. And now, I'm not going to do all of these points and graph all of them for you. Just don't forget the 2 plus right there. 2 plus whatever this was. That made it a little more complicated than what we just did a second ago. Now, if I was going to graph theta is 0 and r equals 2, so I go at a 0 degree angle and I go out to 2, there's a dot right there. That's my first dot. If I had to predict what this thing's going to look like, I'd say it's a little bit bigger than a normal sine graph, which normally would be up there. But then it's got this 2, which means it might be moved from normal. So if I had to predict where this is going to be, I'd predict it end up somewhere like up there-ish, but it's been moved, and that 2 is making me freak out a little bit, like, oh, maybe it's just my radius is getting bigger. See, r equals 2 plus that, my radius just got bigger. So maybe in my circle for my sine graph is just going to be bigger. My radius will be bigger for my circle. All right, so there's a good start. Find the rest of them. The answer key is already posted. You can always go look at it. Make sure you're doing it right. But this is the thing that's going to make you better. If you want to be a good piano player, you can't just like dream it. Got practice. Okay? You want to be good at this test and get the A, which a lot of you can. If you work at it, you can. But this will be the thing. For a lot of you, that'll be the difference. Because you agree that on a typical test, almost every kid makes a dumb mistake. You're human. You're going to make a dumb mistake. So if there's something you don't know how to do, and you're going to make a dumb mistake, well, then you're down to a B. You got to know how to do them all. And then you give yourself license to, okay, I can make a dumb mistake and still be okay and still get an A. All right, so if you're struggling with this, please come up and ask. Here's another one of those find the intersection kind of questions. Don't ignore that negative, makes a difference. Here's a concept checklist of all the things that could be on this test. We have talked about pretty much all of them. Not necessarily all today, but when you include yesterday and today, we've definitely talked about everything. And here are the official review problems. Some of them start off really easy. Don't get like fooled into thinking it's all super easy. Of course, there's a lot of easy ones where you just have to graph them. The only scary part there is if you haven't figured out how R can be negative, you're going to have a problem on this test. So let me help you with this first one here. Anya, do you remember what tip I gave people to graph that if they were struggling with the negative?
You should just graph
1 comma 2 pi over 3. Very good. Let's do that. So I go in the 2 pi over 3 direction, which is that direction. How far should I go in that direction? Only 1. So I go out 1 in that direction, and then my dot is right there. There it is. That wasn't that hard, but that isn't the answer. Mr. T, how do I tweak that now so that it actually goes to the right place?
Because it's like a shadow point, you need to like do it like what's across from it.
All right, so we got to go what's across from it. So this is be important. I'm going to think of it this as like it's over 2 lines in that direction. Okay, so if I'm going to go straight across from that, I'll try to draw a line straight through this, and I hope I hit it. There. I think, yeah, this is so going out 2 lines in that direction. So I think I've done my shadow point correctly. Then that's the actual point. I'll make it blue. That is where you should be. Now, I want to teach you a way that other teachers have taught this, and you might like it. R is -1, you go -1, 1 in the negative direction. Then this 2 pi over 3, the weird part is, now you have to act like you're at 0. That's the like little bit of a stretch. And you have to go 2 pi over 3's in that direction. And you get there. Still get the same spot. Okay. So, strongly recommend do this worksheet, but I'm not assigning it. I'm not saying you have to do all of it. I'm just recommending it. Last test I signed it. This test, I'm putting it in your hands. You want a good grade on this? Then take the time. I also aware there's a lot of kids with a lot of like testing right now. So if you're one of those kids that's probably going to get an A on this test because you got an A on all your other tests, then just maybe practice some of the ones that are the most important for you. Okay? Do what you think is going to help you to do well on this test. I don't want to overload you with extra, what might be busy work for a kid who's going to get an A, because of all the people that are taking IB and AP tests right now. So this is optional, but recommended. All right. And that's all I have for the review for today. Test is tomorrow.